A triangle has side length A equals 22, side length B equals 12, and angle A equals 42 degrees. If possible, solve the triangle. Now, we have two sides of a triangle here, and we have an angle opposite one of those sides. So this is the case, the ambiguous case, side-side angle. And so we're going to just do a quick sketch, and I like to always sketch these in the same way. I've got this kind of horizontal that's going to be the side length C that I don't know yet. And then I've got this angle A that I know, and I know that that's 42 degrees. So I'm going to go ahead and draw something that's about 42 degrees. 42 degrees. And I know this side here that's adjacent to A is the side B. And then my side length A. Now, side length A is 22. It's longer than B, so there's no way that I'm going to be able to draw it down connecting this way, because it's got to be longer than B, which means there's only one possibility, and it's going to have to come down this way. And that means I'm only going to get one triangle here. Okay. So now I know I'm going to get a single triangle, and I'm ready to solve. So I need my third side, and I need these two different angles. So let's start by finding our third side. So this is the angle B, this is the angle C, and this is the side length C. So the side length C is what I'm looking for. The law of sines, to solve for a side length, I'm going to use the form that has the side lengths on top. I only care about the law of sines, the parts that have a full fraction that I know, so that's the side length A and the angle A. So I'm going to do side length A over the sine of the angle A equals side length C, side length B, which is 12, over, I made a big mistake here. I'm not finding, I don't have these opposite, I have the opposite of B, so I need to find the angle B first. Let's go back. Let me talk about that real quick. We have the angle A and its opposite side A. So that's what with the fraction we have to use. But we have the side length B, so we have to find the angle B first. Okay, we don't have either one of the C's, so we can't do anything there. So we have to find the angle B first. So we're actually going to put angles on top for this one. So sine of the angle 42 degrees over the side length 22 equals the sine of the angle B over the side length B, which is 12. And now I can solve for B. Multiplying both sides by 12, we get 12 sine of 42 degrees over 22 is equal to sine of B. And to get the angle B, we use the inverse sign. So the inverse sine of 12 sine of 42 degrees over 22 is equal to my angle B. So now I plug this into my calculator. I'm using degrees, so I make sure I'm in degree mode. And I do my inverse sine of 12 sine of 42 over 22. And I get my angle here. I'm going to round to one decimal place. So B is 21.4 degrees. B is 21.4 degrees. I'm going to go ahead and write that in up here, 21.4 degrees. All right, now notice that I have two angles now. And once you've got two angles of a triangle, you can get your third angle. So our angle C, we know that the sum of the angles is 180, so we do 180 minus those two angles that we know, 42 minus degrees minus 21.4 degrees. Let's go ahead and just type that into our calculator real quick. 180 minus 42 minus 21.4. And we get 116.6. 116.6 degrees. And that's my third angle C. And now the last thing I need is my side length C. So to solve for that, I'm going to use the form of the law of sines where the side is on top. And I'm going to use the A's since those were the original ones given. So 22 over sine of the angle A, 42 degrees, equals the side length C over the sine of the 116.6 degrees. And now I can solve for angle C. So I'm going to do my 22 times the sine of 116.6 degrees over sine of 42 degrees equals C. Now, before I plug this into my calculator, I need to make an important comment here. This 116.6 degrees actually came from a rounded form. And so I actually don't want to use rounded forms as I do more calculations, because every time I round and then use it in the calculation, my next thing could be off even more. And so what I'm going to do is I'm going to take this original, I'll do my 180 minus the 42, and then instead of minus the rounded form, I'm going to subtract that whole thing that gave me that number. And this thing, I'm going to store it in a variable, okay? Now this angle, that was the angle C, so I'm going to store it in C. Store in the variable C, and hit enter. So now I've got C, and now that's this angle here. Now I'm going to go ahead and type that in, 22 sine of the angle C, and then over sine of 42. And this way I'm not using a rounded form in that calculation, and I get my side length. Okay, round that to 29.4. C, side length C is 29.4. Now that rounding, sometimes it matters, sometimes it doesn't. Let's just, for the heck of it, let's go ahead and just type it in if we had used the rounded 116.6 and divide by sine of 42. See how close it is. So you can see we actually, when rounding, of course, we round to one decimal place, it's the same. But it was off a little bit, right? When we used that rounded 116.6, it's a little bit off of what it actually is. So, and that was just one rounding step that I did previously. And so you can see how if you keep rounding every stage, it can build pretty quickly and kind of throw your answers off.